Hello everyone, welcome to my channel. So today we are going to do Leetcode weekly challenge. Third question, and this was a hard level question. This time Leetcode had given two hard questions, one easy and one medium, right? So that's why this time contest was somehow like now they are getting towards some more harder things. So yeah, this was one of the hard level question as they tagged. So let us go ahead with this question. First about the question, reading this and then understanding it through some dry run about the constraints, and then we will be building up the intuition behind the same. And before starting that, I want to introduce you with Newton School Coding Contest. So basically about that, everything you could figure out in the description below, you can register there. And as you are already doing these contests from means Leetcode bi-weekly, weekly, and even the daily challenges, so it would be much more beneficial for you if you try out these contests as well. Because the thing is, the more you practice, it would be much more beneficial for you for in your interviews and even in your online assessments. So that's the whole thing. So now let us go ahead with this particular question. So here you are given zero index arrays, num and cost consisting each of n positive integers. You can do the following operation any number of times, increase or decrease any element of the array nums by 1. The cost of doing one operation on the ith element is cost of I, and then return the minimum total cost such that all the elements of the array nums become equal. So the thing here is that you are given with the sums array and corresponding to that cost is being given, and that cost is basically the occurrence of that particular element. Means the thing is they have given us this particular one, then one occurs two times, then three, it means three is occurred three times, the cost which is given, then five occurring one time, and then 14 which is there means two which is there, it will be occurring 14 times. So that's the thing. They are giving us with the cost and the nums. So this is the thing which is given to us. Now, before going to this example, let us see the constraint. So basically length and cost length same. Okay. And n would be 10 raised to power 5. So we can go ahead with n log n solution or n solution, not n square. Because if n square then 10 raised to power 10 it would be. And this particular means each element can go up to 10 raised to power 6. So that's the thing which is given to us. Basically, if we multiply them, then only there could be issue in some data type, else there won't be. But let us go with this example and then we'll see to see. Now, here the thing is this nums and this cost, right? So we can make all the elements equal to 2 in the following way. Now they are just explaining how they got the output. I'll explain you that how we need to choose this particular 2 or any other. That's the thing. So increase the zeroth element one time, the cost is 2. That is they are saying about this, right? And how cost is 2 because 2 is the given. So if we increase by plus 1, right? So then only it will become 2. And cost is also given as 2, right? Multiply by 1. 1 is the times we are increasing it and 2 is the cost which is given here, right? And why cost was 2? Because 1 was occurring 2 times. What I'm saying, I'm again repeating. So the thing is this 1 which is given to us, right? So 1 is occurring 2 times. That's why its cost is 2, right? And for getting this 1 to 2 means basically to this number, we are required to add 1 to the same, right? So that's why we are multiplying what we are adding or subtracting to this number here, right? And the cost which was there, that is 2. So that we are multiplying with the same. So that's why our cost becomes, overall cost basically becomes 2. Now next thing they are saying that first element which is there means basically this 3. 3 is occurring 3 times, right? So they are saying the cost is 3. And how cost is 3? Because for one element it is 3, right? So 3 is occurring 3 times. So now we will add subtract 1. Here also subtract 1. Here also subtract 1, right? And our cost is basically 3, right? So after that, after doing the same, we will be getting our overall cost as, oh, 1 minute. Is there some mistake in the same? Because this 3 which is there and 3 which is the cost. So, okay, let us check. Then in this first, this is 3, right? So after multiplying by this 3, it should be 9, right? And then 5, because we are required to get to this. So here just 1 would be added. And then now 5 is there, whose cost is 1. That is 0, 1, 2, second element. 3 times, okay. I guess, yeah, they have just, but still you can see that in this second element, that is this 5 which is there, they are saying that element 3 times. Okay, that we can agree because 5 minus 2 is equal to 3, right? So 3 multiplied by 1 because 1 is the cost of the same. So that's why we are getting this as 3. So this is correct. And zeroth element, which is 1, that is also correct. But why they are saying for the first element cost is only 3? I've also created the explanation. It was also same. Let me check that. Get back. Okay, it was just like I just got confused in the same. So here the thing is this 1 was all right. 2 is the cost. But here this 3 which is there and it is occurring 3 times, right? And basically the earlier thing which we were doing, 3 can become 2 by minus 1, right? And the cost here is 3. So we are not required to do 3 into 3, we are required to do just 3 into 1. The earlier we were doing means the cost which is there, that is this 3, because according to cost only we were writing 3 times, right? And multiply by what is the subtraction between the number which is to which we are required to reach and the number which is going to reach there, means basically 3 minus 2. So that is the thing which we are required to do here, and that's why they have given us 3. And now comes the part for this 5. So for this 5 is occurring just one time, right? And for 5 to become 2, we require minus 3, right? So that's why cost is for this particular 5 is 1 multiplied by 3. So that's why it is becoming 3. And that's how we got our answer. So this is the thing which we have explained in this example. Now comes the next step, that exactly how they use this example. So now let me explain you by the example which I have wrote. Okay. So this one was the first example only. Hmm. The first example which was there, right? So like this, that particular could be expanded. And now comes the part for here, that let us check one by one that if we make all the elements equal to 1, because here starting we are having 1, right? So if we make all the elements equal to 1, so here it would be 0 and all the 2's will correspond to 1, right? And 3 would be corresponding to 2 and 5 will be corresponding to 4, right? So we will be getting 24. And then if we make all the elements equal to 2, then that already I have explained how it got to 8. And then let us check that we make all the elements equal to 3. So again, the things would be that 1 would be difference, it would be having 2, and then again 2. For 2 it will be 1. For 3 it will be 0, and for 5 it will be 2, right? And then according to that, if we add up all the cost, right? So it will become 20. And for 5, it will be something like this, right? So that's why we got to 50. Now if you can check that overall cost of all, only this one is minimum. And let us draw a graph for the same. So graph would be like when we are trying, means this is corresponding to the starting element. Oh, what was that? Hmm. Okay. So this is corresponding to the starting element, which was 1. This is corresponding to other 3, and this was for the 5. So this was the thing. So if our element is at the starting, so here it is the cost graph. When it is in the middle, 2, and then when it goes ahead, and then for the last element. So basically you can see that our particular means all the elements which are present there, they all are converging towards the middle element. Then we are getting the minimum cost. You can clearly see here. If we check for the second example also, I've taken this by my own. So 2, 3, 1, if we expand them, then it becomes something like this. Then try to make equal to 2, right? So it will be uh, equal to 2. So 3 minus 2 would be 1, right? So that's why 5 times 1 would be there, and last that is 1. Then 1 plus 1 is equal to 2, right? So that's why it will be again equal to 1. Now making all elements equal to 3. So for that fact here it would be 0, but this 2 minus 3, that will be 1, right? So that's why 2 times 1, and the last one that is having 1. So it corresponds to 3. Now comes the part that make all equal to 1. So for this purpose, right, and our 1 was present at the last here. So if we check that here 1 which is there, even if it is present at last also, still we would be required to sort it. So after sorting, it will be something like this. Now 1 would be here, 2 would be here, and 5 would be here, right? Now the thing is that after sorting them, then make equal to 1, right? So when we are trying to make it equal to 1, I've written all this, means I've written all these as as per this particular. So that's why 1, 1 for this 2, and then for this 3 we would be in 5, and then 0 for the 1. So now here the part is that we for this particular we got 7, right? When we are trying to make it equal to 1, and minimum out of that was 3, right? Our cost was equals to 3. So here also in this example also we can check that when we are required, so here this was for 1, 7, and this was for this particular 2, means 2 was having the 6, and this was for the third element which is there. That, let me change the graph here. Actually I hadn't sorted in this. So for our 1 we are having 7, for our 2 we are having 6, and for our 3 which is there we are having 3. So here we can easily check that when the number is basically as per the count, right? So as per the count when the number is in the middle. So here if you see 3, 3, right? So which one is the middle? You can clearly see that this particular lies in the middle, right? But this is not exactly the middle, means not exactly the way we find middle. It is in actual the median, because it is also related to the cost as well, right? So that's why you can clearly see that when a median is there and we make means when we converge all the elements towards that median, then the cost is minimum. So this was whole context of this question, that we are required to make all the elements equal to the median of the array which is being given to us. So this is whole concept, and that's why for doing the same thing, we would be required here to do this particular question by using a binary search, so that we can check out for the middle elements, and then whatever middle element is there corresponding to that only we can check out for um, our final answer. So this was overall explanation for the same. Now let us go ahead for the coding part for the same. So, and this was really interesting question because of this fact only, that it required a lot of mathematical things. to get into the same. So now I had tried a lot of things for the same, even to easy binary search. So let us start with the same. I'll explain you the whole code that how it is required to be written. One minute, I'm trying to. That whole code is basically visible. Yeah, better. And now I can open up this one also, so this won't be a hurdle now. Okay. Now we can check here that this particular which is there, this we are taken, this we have taken some auxiliary function. Now other thing would be there. This is our main function which is there, right? So this main function was giving us nums and cost, and we are required to return long. As I was saying that the constraints which is given to us in such a manner that it will also exceed our integers. So that's why here by themselves they are giving us return type as long. Now comes the next part. Here we are taking low and high, and why high is being taken as 10 raised to power 6 because the element can go at max till 10 raised to power 6, and that's why we are taking. Now comes the next part. Here we are doing the binary search part. So I usually use this method of binary search, low less than equals to high. In this particular, we will always be getting our answer in the mid, whatever it is there at this middle. So and this particular type of middle I'm taking so that there is no overflow condition. And now here we are basically calculating three types of sum. And these three types of sum are basically for mid minus 1 and mid plus 1 because we are required with median, right? So that's why we are required to go ahead with this type of approach. So here for the middle, what I'm going to do is that we are first required to get the sum, and this sum is basically for that fact that k means that cost into subtraction of element which is there presently are the middle element which is there. So this is what we are doing here, and here we will be passing the middle element and which we calculated from this point. So that middle element thing which we are going to do here is by this particular. Here you can see this nums, cost and mid which is there, right? And now here we are going with the long sum which will be storing our answer. So this is that part which I had last time explained, that cost multiply by our element which is there minus the middle element which we have passed. So here that thing only we are doing. We are traversing to that size of that num, right? And after that, we are doing that absolute part because there were elements which were giving us minus 1 or 1, right? But were required just to multiply with 1, not with the sign of the same. So that's why we are taking that absolute. So here's that k value, and here's the cost of I. Cost of I simply refers to that element corresponding to which that cost was there, right? And we are adding that to our sum, and at the end we are returning that sum. So basically in this what we are doing is we here if we want to make our element equal to 1, right? So we will be calculating for all of these that what is the exact sum of cost and subtraction which we have done, and finally we will be returning that particular sum. So that's the portion which we are doing here. So this was done for the middle part. Now comes the part for the mid minus 1 and mid plus 1. And for that purpose, we will calculate, and after that calculation, now we are required to check that if a sum 1, that is the sum which we got from the subtraction of middle element, if that is less than or equal to sum 2 as well as it is less than equal to sum 3, then we will be returning our sum 1. These all things which we are doing is just corresponding to that median thing only. And then if that is not the case, then we are having this case because of which we are pushing our elements toward that element which will converge our answer towards the lowest cost. So that's why here we are checking that if a sum 2 is basically less than sum 1, right? So you already know that in a binary search, if we are required to reach a particular element, right? So for reaching to that element, here you can see that sum 2 is basically less than sum 1, and our sum 2 is here, this this one where we were passing that mid minus 1. That is, it was from the higher part only, right? And still our sum 2 is basically less than sum 1. So that's why we will be pushing it towards more of this side. So that's why we are doing this mid minus 1. Now comes the part for sum 3. So for this sum 3 is less than sum 1. So basically our sum 1 is that mid plus 1. So that was from the leftmost side. So we were going towards this side. So that was for our sum 3, right? So for that purpose, if it is still less than sum 1, that is, it is still less than this particular. So we are pushing it more towards this. So that's why we are making it low equals to mid plus 1. And this particular whole thing is running in this particular while loop only. So whole thing would be repeated until and unless we get that final answer, because we have put our return statements here only, right? So the thing is, the way I'm doing this particular thing, so my answer would be returned when my element is means my answer would be returned in the middle element, and that middle element answer I'm getting from this sum 1. So that's why I'm returning from the sum 1, and if nothing is there, so at the last I will be returning as 0 as the answer. So this was all for this particular question. I hope you liked the explanation, and yeah, time complexity and space complexity for the same is, so basically we are not using any extra space. As you can see, we are only there is part for the space, time complexity. So the time complexity for the same is log of n, and the space complexity for the same is order of 1. So this was all for this particular question. Hope you like the explanation, and if you like this, then please do like and subscribe to my channel and do share with your friends. So this was all. Thank you.